Welcome to the unit on algebraic expressions, Surds. The objectives for this session are to understand that surds can be used to give exact answers to calculations and manipulate surds using the formulas shown. Root AB equals root A times root B, and root of A over B equals root of A over root of B. Let's begin by defining a surd. So if n is an integer which is not a square number, i.e. it's not, for example, 4 or 16 or 25, because each of these can be square rooted to a whole number. So n is not one of these numbers, for example, then any multiple of root n is called a surd. So let's have a look at a few examples. Root 3, root 17, 6 root 2, and so on. Now, irrational numbers cannot be written in the form a over b, where a and b are whole numbers or integers. Surds are examples of irrational numbers. They cannot be expressed in the form a over b. The decimal expansion of a surd never repeats and is never ending. For example, root 2 equals 1.414, and so on. Surds can be used to give exact answers to calculations. We're going to have a look at some rules for the surds. So root AB equals root A times root B, and root of A over B equals root A over root B. Let's see how these rules can be used in examples to simplify expressions. Take a look at this example. Pause the video and have a go. Press play when you are ready to view the solutions. So let's have a go at example 1a. Simplify the square root of 27. Now the square root of 27 can be expressed as square root of 9 times 3. This can be further broken down as root 9 times root 3. And of course root 9 is equal to 3, so the entire expression is 3 root 3. Now for example 1b. Simplify the square root of 45 over 3. Again, let's break this down. So 45 equals 9 times 5. And then break it down further. Root 9 times root 5 using the first rule. Root 9 is 3. Root 5 remains as it is. And so does the 3 in the denominator, giving us root 5. Now simplify the expression shown. Again, let's break this down. We're going to check for common factors and square numbers in particular. So 60 can be substituted as 15 times 4, and 135 can be written as 15 times 9. Hopefully you should be able to see that 15 appears in each of the roots. So let's put aside the root 15s in each of the terms, as we've done here. Root 15 times 4 using the first rule is root 15 times root 4. And similarly for the last term, we have root 15 times root 9. Let's simplify the square numbers. So root 4 becomes 2 and root 9 becomes 3. And of course we can tidy up. So 2 times 2 gives us 4. And we put the 3 at the front here. And finally we can start to simplify because we have 3 root 15 minus 4 root 15 plus 3 root 15. To give us 3 minus 4 plus 3 times root 15, which is equal to 2 root 15. Now have a go at this example. Pause the video and have a go before proceeding. Press play when you are ready to view the solutions. So let's solve example 2a. Expand and simplify where possible the expression on your screen. Let's expand. Root 3 times 7 and root 3 times minus root 2. We bring the 7 to the front as this is the convention. Root 3 root 2 becomes root 6, giving us the expression shown. And now for example 2b. Expand and simplify the expression on your screen. So let's expand. 5 times 6 is 30. 5 times root 2, minus root 2 times 6, and minus root 2 times plus root 2. And now let's start to tidy up. Let's leave 30 as it is for the time being and deal with it later. Tidy up the root 2's. 5 root 2 minus 6 root 2 is minus root 2. And leave minus 2 as it is. Now let's tidy up. 30 minus 2 giving us 28. And of course minus root 2 can't be simplified further, giving us 28 minus root 2. This brings us to the end of this session. If you have understood its contents, you should be able to understand that surds can be used to give exact answers to calculations and be able to manipulate surds using the formulas, which are shown on your screen. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises related to it in your textbook.